Okay, nobody curse.
Yeah, please don't curse.
Ain't gonna work, man. Ain't not gonna work.
I should be getting here.
You might have to crop a little bit at the beginning.
Yeah, of course. I don't even know if the memory on my phone is good enough
That's
to
what
do
I'm saying.
this.
It's such BS that you expect you to have all the data and battery to be able to film yourself.
Man, I just hate.
My handwriting is so much better than this. I was getting there.
Dude, are you serious? Peanut.
Oh, I didn't know Sadie was left-handed.
You want me to rewrite it?
Sadie, you're left-handed?
Yes.
I had no idea.
You don't really know that. Give me that shit.
Alright, let's get started here. I'm gonna write the problem up here, and I want y'all, as soon as you have the information you need, start working the problem so we can see if.
Can you write it a little darker?
A 1 liter bottle.
$15 milliliters is
Of gas.
0.5 liters.
Yep. At 1.3 atmospheres.
So, 1 liter bottle contains 50 milliliters of some gas at 1.3 atmospheres and 5 degrees Celsius. So, the question is, if we were to drop this bottle into a lake and it sinks, so the pressure, what's going to happen to it while it sinks? The pressure. The pressure will be increasing, right?
Kind of like whenever you dive and your head gets like.
Yeah, basically your ears, you start feeling your ears implode. So let's say once it sinks, so it sinks, and the new pressure, I'll just put P2, is now 1.52 atmospheres. That's your P2. And the new temperature is, is 2.09 degrees Celsius. The question is, what is the new volume? So T1, okay, 3. Now this one is very basic. It's probably one of the first ones we looked at. So the first thing that we need to do when we look at this is look at what they gave us and look at what they want. So first of all, they give us a pressure, they give us a temperature, and they give us a volume. And since all of these things change, what equation do we use?
Combined gas law.
Good. We need to combine gas laws. So we need P1 V1 T1 is equal to P2 V2 over T2. So since we are solving for V2, we can just rearrange the equation for V2. Again, this is where a lot of people kind of mess this up. It's just arithmetic. But since we have to divide out a fraction, it is inverted on the other side of the equation. This is very important. I think this is one of the main ways that people kind of mess this up. So it's going to end up looking like this. V2 is equal to P1 times V1 times T2, all that over T1 times P2.
Wait, so where are we getting the volume?
Does everybody see what happened there?
I don't know where we get our volume. Volume is 1 liter.
Those black
So
and
what
white.
does 1.5 of gas have to do with it?
Those are dead.
Oh.
Yes, ma'am.
With the temperature, don't we have that converted to Kelvin, so we add 273.
Yes, so that's another thing that we could probably
And then
do
we
right now.
convert milliliters to liters, right?
So what is let's just do this. T1 is equal what? Let's do this in Kelvin, so 5 plus.
278.1.5.
And then T2,
275.26.
What does the 50 milliliters of gas have to do with it?
point, what, 26? Okay, that's our new temperature, so whenever we do that, we'll put Kelvin. What was your question?
What does the gas have to do with it at all? The 50 milliliters of gas?
That's our volume.
I thought our volume was supposed to be the 1 liter volume.
No, it's the gas, how much gas you have.
I guess I see what your question is. Contains 50 milliliters of a gas.
Yes, ignore the 1 liter part.
So, the volume of the gas, I guess we don't really need to even worry about this. This is the volume that we're looking at. What's gonna happen to the 50 milliliter volume? The bottle itself doesn't change in volume. Yeah, that's a good question, but don't get hung up on that. Forget about the 2 liter bottle part.
So what's the question I'm gonna ask?
What's the new volume? V2. This is our V1. Let's make this V1.
What's the answer?
You got one already?
0.423158.
Alright, hold that, write it down somewhere. Because like I said, I changed some of the numbers. So the answer that we get is not the answer that it's supposed to be. So we'll just look for a consensus. Alright, so what you should have is V2 is equal to our P1.
I'm not even there yet, it's just these.
Well, just keep going while I'm doing this, alright? I'm just writing it in.
I didn't get it.
1.3.
It's not 0.05, it's got 0.4.
P1 and then V1 is 0.05 liters. Everybody sees why that's the case, right? Change milliliters to liters.
Oh, yeah, 0.05.
That's also an important step. So T2 is 275.26. Okay, got it. Now all that divided by T1, which is 278.15.
Do we know T?
T2 is
And
275.
P2 is 1.5. 1.52 atmospheres. So, in theory, put this in your calculator. Is that what you did?
Oh.
Not like that, but I can't see the numbers.
Where'd you get a 13?
1.3 atmospheres.
So how'd you make the equation equal V2?
Divide
Can I see your
from one
calculator?
side to the other.
Thank you.
It's like in arithmetic. You have P1 over V1 over T2 equals T2 times V2 over T2. So you divide one side to get put down the other.
Okay,
Can we do that?
yes, I'll do that for you. What did you say you got?
0.423158
Is
liters.
it 0.04233158?
Yes.
Is that what you got? 'Cause we- yeah, I got this.
0.042419.
0.0423.
Yeah, that's what I
Mr. Steve, is there a way to like,
What is the units?
Liters.
Liters. Don't forget to write your units on your answer. Yeah, I've been kind of forgiving about that, but like I said, you guys go to college and you start doing these in a, for your professor, they're just gonna run through, they got 200 something papers to grade, they're not gonna sit there and, try to figure out if you have the right units or not, they're just gonna mark it wrong.
Do we always have to put it in liters?
Yes, generally, because that's the standard volume, liters. If we converted all this stuff to liters, then yeah, it has to be in liters. But sometimes the problem will specifically ask you for it in milliliters.
Cause I was just thinking if it started in milliliters,
Then you could leave it in milliliters. I mean, especially if the problem says, how many milliliters do you have or something like that.
So it's 0.423.
That's what I got. Anybody else got that?
Yep.
You got
Zero.
You got 0.04?
I got 0.0427.
Yeah, I didn't get that.
So where you might have gone wrong is did you put your volume in like this?
No, I didn't.
Can I leave it
Yes.
milliliters?
What did you get in milliliter?
The same thing, just the decimal move,
What is it?
42.3158.
Yeah, that's accurate.
Is it 0.5 liters or 0.05 liters?
Point oh five.
Oh, it's
0.05.
Do we round it?
So can we do that thing where we change the V2, like we made V2 the subject of the.
Okay. So that's pretty important.
Mr. Steve?
Muy importante. It's
Actually, I'm gonna do the same thing with a different problem. Well, I'll do this for you real quick, and then I'll do the same thing with a different problem, because that step in the next problem is very important. Muy importante. So, this is the part you're talking about, guys. So, we have this, right? The basic rule is that if we do something to one side of the equation, we have to do it to the other side, right? And since we have V2 in all this mess, we need to get it all by itself. So we divide this out. By doing that, it cancels out because we divide it by itself. You know, it's divided by itself, P2 over T2. But because this is a fraction, there's some property in mathematics where when you do a fraction divided by a fraction, it's the same thing as multiplying it by its reciprocal. Okay? It sounds like a lot, but it's just a rule in math. So that means that we multiply the other side by its reciprocal. So because we divide this out, this all cancels, but on this side, we end up with T2 divided by P2.
We divide by a fraction.
Because we divided a fraction by a fraction, which is the same thing as multiplying it by its reciprocal. Because P2 over T2, so it's going to cancel out here because it's the same thing as multiplying it by its reciprocal. And as we've seen before, when you have the same thing in the numerator in one and the denominator in the other, they cancel out. So on one side of the equation, this happens. See what I'm saying? So we do the same thing on the other side, though, and then we wind up with T2 in the numerator, P2 in the denominator. So it's kind of messy, but you know you can skip a lot of steps once you know what you're actually doing. So then you end up with V2 is equal to T2, P1, V1 all over P2, T1.
So if you wanted to get the P by itself, you just, well, if you wanted to get the T by itself, what would you multiply by?
So let's say T1. So you want to get T1 by itself. You would multiply, so this one, you want it by itself, it's a little more complicated because it's in the denominator. So you multiply both sides by T1, it's gone from this side, and now it's over here in the numerator, but now you have to divide out all of this.
Couldn't you just multiply